Hello and welcome back to another video with It's Dr. Dan, and what we are going to be looking at today is density. Specifically, we're going to look at the properties of matter and then discuss what is density, which is a common conversion factor and term that we use to describe different properties and something that we utilize very often in chemistry. So before we even talk about that, let's look at what matter is so that we can understand where does this property come from. So matter, just as a basic definition, is anything that occupies a volume and or space. And when that occupies that space, it also has a mass to it. So if you think of your computer or your phone, for example, right, it has so much space to it, and you can also put it on a balance and get its mass. Now, if how else can you tell if it has matter? It's something you can actually have observations to see it, right? You can touch it, you can taste it, you can smell it, feel it. Because of that, that's what describes it as matter. So it's something you can interact with. Now, whenever we have these different types of matter, well, they all have different types of properties that you can use to describe them. Now, all these different properties, these are just referred to as characteristics that you can use to try to explain the quality of that system. Now, in science, we usually try to split those two types of properties. We like to describe physical properties, so things that you can actually easily observe, and chemical properties that generally help describe how the actual material behaves if it's to go through a reaction, like if something's flammable, for example. We're going to more specifically look at the physical properties because the first thing is whenever we have the different physical properties, they can be broken down into two categories. So if you think from before, we had physical and chemical, and now these even break down even farther, right? Little subcategories. So the first one is just essentially anything you can usually do in the lab, right? So extensive properties is something that it changes if you add more if essentially you add more matter to it, so you just keep adding things to it, that's going to change that property. So for example, if you have size, length, volume, mass, weight, width, if all those things can increase if you add more of whatever the object is. So the example that I sometimes commonly use is, let's say if you have a coin or like a penny and you just have one of them, well, you just have one coin. If you have two, three, four, five, or six, well, now you have multiple of them. And if you were to put them, let's say, on a balance, the mass would theoretically double, triple, quadruple each and every time. So that's an extensive property because the more matter you added, the higher the mass got. If you were to try to measure the length of one penny, right, you would get, maybe a little bit under a half an inch. If you had two of them, you'd get a whole inch and so forth, right? It continues to double. So this is just a normal measurement, right? Now, an intensive property is something that you can use to define a characteristic of whatever type of matter it is, meaning it can be something that is potentially a little more unique for that item. So, for example, maybe the color, right? So going back to the penny example, it has a copper color. You have an idea of how to help identify a penny versus maybe a quarter, right? That has a more silver characteristic to it. Odors are another thing that could be very unique for different things that you see every day. One of the great examples is think of food, right? How can you tell different foods? Is a lot of times by your smell, right? If you go in the kitchen and something's being cooked, you can get an idea of what it is. Other things has to do with the states of matter, so solids, liquids, and gases, and how they can change between all those different states. The temperatures of when they change is going to be different for every single type of thing that you're looking at. And then the last thing is the density, which is what we're going to be looking at in this video and trying to get an understanding of really what is it. And then we'll show a cool video of really us seeing it in live in action. So let's take a look at what is density. Okay, so what is density? What does that exactly mean? Well, one of the common sayings we like to say to people is, how dense could you possibly be, right? It's whenever you're a little bit hard-headed. Now, that comes from the idea of what density is all about. An easy-ish way to get it, it has to do with how much mass is occupying a given volume. So one way to look at it is think of solids, liquids, and gases. If you think of the containers that I have above, now if I have a solid, like let's say a block of metal, for example, if you were to throw that into water, would the metal just float on the top or would it sink? And you can think to that, right? It would sink. Now, why is that? Well, it has to do with the density. It has to do with how closely packed are those little atoms towards right next to each other, right? So if I have all these little orbs here, you can see they're all really nice and closely packed together. So we're fitting a lot of mass in a very, very tiny area. Versus, let's say, a liquid. Well, okay, if I have all these little orbs, you can see that they're a little bit more spread apart. They're not as close together. It's not as thick, right? So if you have something like water versus maybe like vegetable oil or honey, you can kind of see each one of them has a different viscosity to it or a different density. So it's something that it can vary between liquid to liquid. However, something like a metal block is going to sink right to the bottom. They have different amount of matter jammed packed in one little vessel, right? And all these are the same size vessel, but depending on how much mass or matter you have jammed in there, it's going to have a different density. And the last one's a gas, right? When you have gas particles like what you're breathing right now, you're breathing oxygen and nitrogen, all those gas particles are free flowing all around you. Now, there's trillions upon trillions of atoms that are very far spread apart around you, and they're not so close, densely packed together that you can easily see it, right? Now, what is a way for you to maybe see it? Well, let's say if it gets, think of water vapor, right? So water can either be solid, liquid, or a gas. Well, if it's very, very cold outside and it starts getting very, very foggy, that's when that water vapor starts to condense a little bit thicker and thicker, so it's a little denser. Versus when it's a nice hot day, you can see it's more spread out and it feels a little bit more muggy and humid. So the entire definition of density is it's the amount of mass per unit volume. So what we're actually going to be doing is combining units together because we're interested in how much mass occupies a given space. Now, why is that so important? Well, this is where this is one of the intrinsic properties of matter. So if I had, let's say, an example I like to use in my classes here, I have lead beads on the left, and then I have a pool noodle. And if I ask you which one do you think is more dense? So something, what it means by more dense means that there's more mass in a given volume. Now, notice how they're both completely different sizes. And one of these, you know for a fact, floats, right? You've probably had a pool noodle at some point in your life. You've been around a pool. It floats. Now, but it's massive. So does this have a higher or less density than lead? And you can probably think, well, lead's a metal. It's going to sink right away. So that's going to have a higher density. And that's because there are more atoms jam-packed into one small area that can be easily measured. So within that 5 millimeters of space, there are more atoms jammed together, and that's a unique value for lead versus something that's more of like a styrofoam that's going to have its own unique value for it. So what we're going to look at next is, being that we do have that intrinsic property of that's available to us, it's different for every material. We can use it as a method to identify things. All right, so what we have here is a video from davehacks.com, which is on YouTube, and he made a density demonstration here. So what he's doing is he has a glass of water, and he put water in there, and he's going to be adding food dye to it. So water has a density of 1 gram per milliliter. So this is usually what we use as a metric to determine, will something float, will it sink? So usually metal will sink down to the bottom of the glass. Something that's very, very low density will float on the top. So he'll have those mix up so you can always see that water layer. He'll mix it up. Now what he's pouring in there is this honey liquid. And what you can see immediately is that it sank right down to the bottom. So what does that exactly mean? Well, that tells you that this has a higher density as a result. So if it sinks, it has a higher density. So greater than 1 is what that means. So it sank right away. So now even when you pour in a little bit more water, you'll see that, oh, the water didn't sink into the honey layer. It still added to the blue layer. It didn't do anything. Now, when he adds oil on top, which is very similar to like thinking a salad dressing, which is that oil and vinegar layer. Vinegar is very similar to water, it's a very similar density. The oil goes to the top and then the water is on the bottom. So that tells you oil has an even lower density than water. So oil floats, let's say it could be like maybe around like 0.7 grams per milliliter. Water's around 1, and then maybe the honey is around 1.3, for example. So you can kind of see that layering effect. Now, even when it can, you could have like all kinds of different effects here. So one of the things he's going to do here in a second is drop different objects in. So you can see he drops a bolt in and it sinks right to the bottom. And that makes sense, right? Metal sinks. That's like our lead beads that I showed earlier. Anything that's metal has a very high density. It's usually greater than, typically most metals are greater than 7 grams per milliliter, except for maybe aluminum, which is a little bit lower, but it's very, very heavy or very, very dense. Versus, let's say he puts a grape in. Well, a grape is a piece of fruit. Well, let's see what happens here when he puts that in there. It sinks right through the oil, right to the bottom of water, which makes sense. But notice how it floats right on top of the honey. It doesn't go any farther. So what does that tell you? So the metal has a higher density than everything. Then the grape has a higher density than water, but it's lower than honey. Now, on the next one, what is he going to add in now? He has a plastic bottle cap. He puts that in, and you can see it's going to float right on the top of water. So it's like having like that trash layer float. And then you have a piece of styrofoam that floats on top. So all these densities are different. So it's like a ranking of density, right? So lowest is all the way on the top, and then the highest is on the bottom. So that's density at work. And you can do any of this at home with household chemicals and stuff that's laying around. So as I mentioned, density is a permanent characteristic of any substance. So if I have any liquid or any solid, they're all going to have their unique density values. We can use that to determine whether or not something is a very specific characteristic. There's methods that we can use to try to figure out what is it that we have. So for example, let's say if I had water, ethanol, methanol, and benzene, and I were to dump, let's say, the water and benzene into this beaker here, what would happen? Well, think about it. Which one is a higher density? Well, water has the biggest value. So if I were to pour water into this beaker, it would end up sinking to the bottom, right? Just like in the video, it would have, being that this one would actually have a higher density. Now, if instead, let's say if I had benzene, where would that go? Well, being that it has a 0.876 grams per milliliter value, it would end up floating on the top. So you would see a layer of benzene on the top. And being that these two are not soluble with one another, you would see them end up separating as a result, just like in the video. So this gives us an idea of what type of different properties we might have, but depending on what it is that you're looking at. So let's take a look at some examples. How could we actually apply this in the classroom? So suppose you forgot to label the following beakers. You have 3 beakers. Each one of them has 230 milliliters of a clear liquid in them. How would you determine which one is water, ethanol, and benzene? Well, how could we try to go about through that? Well, let's try to think about it. What exactly is density? Let's take a look at some tips and try to understand what it is that we have. Thinking of density as a formula, meaning that density is equal to mass over volume. So whenever we have a density, typically we end up showing this at putting a D here as the letter to use. It's generally the not capitalized version, which is equal to density. And that is going to be mass over volume. Now, this is more commonly referred to as grams over ml whenever we are using it, and we can treat it just like a formula. So if you were trying to go back to our last problem and we were trying to figure out, well, which one do we have? Well, we could try something simple characteristics, right? We know the volumes of the three beakers, right? All the liquids were 230 mLs. So we already have the value for this bottom piece that is here. So how could we end up trying to figure out the other? Well, we need the mass. Well, what do you have available to you in the lab? Is there anything you can use? And you'll quickly remember, oh, we have balances. So what if you just weigh the different liquids that you have? Why not, right? You can put the beaker on the balance, weigh it, and determine exactly how much that liquid weighs. So let's go back to that example. So let's say if I weigh the first one, right, and you determine that it weighs 202 grams. So what we could do is, okay, I have 202 grams. I could divide that by 230 ml. And what would you end up getting for your value? You would quickly see that you would get 0.878 grams for every 1 milliliter, right? If we simplify that fraction. So using your calculator. So if you just do 202 divided by 230, you'll get 0.878. So which one is it? So if we go back to our chart from earlier, 0.878 is very, very close to benzene. So we can see that this one is 0.876. They're about the same. So let's say that the very first one is benzene. And that's just one way to do it. You could get the odor possibly, maybe do some other different chemical tests. This is an easy one that's available to you at your own home. Okay, so what about the second one? Let's say if I do the same idea, I measure the weight of that one too. So we get 229 grams. I divide that by 230 mLs. And when we get our final number, we'll get 0.996 grams per milliliter. And we can see that, oh, well, 0.996, that's very, very close to water. So that means that our second one is going to be H2O. Now, is this the only way you can do it? Well, let's take a look at another tip in order to figure out the third way. Right, so there's another method to solving for these. The last way to think about density. So the first way was think of it as a formula. The second way is to use it as a conversion factor. This is one of the few conversion terms that you have that allows you to go from mass to volume. It's a bridge. It allows you to convert from one type of unit to another. It allows you to derive new values based on things you can find in the lab. So if let's say I have water, right, which is 1 gram per ml is its density, we can write this as a conversion term by saying that, okay, 1 gram is equivalent to 1 milliliter, like a fraction, or we could flip it to use it for however you want to cancel out units, right? So if I had 1 ml, you could also say that's equal to 1 gram for water. Now, what exactly do I mean by that? Well, think of the example that we were just doing. Well, earlier we had 230 milliliters was the volume you measured. So if I were to take, let's say, one of the densities, and we'll use the density of methanol, which was one of the other ones that was in that table. So if I want to cancel out my units, how would you end up trying to do that? Well, the density of methanol was 792 grams over 1 milliliter. So what would I put on the bottom here to cancel it out? Well, milliliter needs to be opposite of milliliter for them to cancel, right? Units need to cancel. This would leave you with 0.792 grams on top. This would give you grams. So once you go through the math for that, you should have 182 grams. So if you were to measure any of those beakers and if any of them equaled 182 grams, that means that you have your answer. So let's go take a look if we got it correct. So if I go back up to my 3 beakers, is the last one 182 grams? It is for planning purposes, but you could have did that in the very beginning. You could have calculated what any of your values are and then solve that way as well. there's multiple ways for you to use density. Don't forget it because it's going to be a very useful term for when you get to dimensional analysis and stoichiometry and solution chemistry. Density is very, very handy. Let's go look at another problem. Density. What is the volume in liters of air if the mass is 100 grams with a density of 0.001184 grams per milliliter? Okay, so if we were to do this problem, first thing we always want to do is we want to write down what our desired and our given terms are to help keep ourselves organized. So the first thing, what do we actually want? We want volume and we want it in liters. So we're going to write that down. Now, what else were we given in the problem? Well, if we take a look, we have a mass here that we can write down. So let's do that. So which is 100 grams. And then we also have a density, which is available to us too. So we will put that down as well, right? We have this density. So that value is 1184 grams for every milliliter. And we could also have the flipped version as well. So I like to write down all possibilities. So that way we can see, okay, how can all these little pieces plug together because unit conversions can only fit one way. All right, so based on these terms, which one would make more sense to start with? What we have is we have a conversion factor on the bottom, and then we have a term that's by itself on top, aka your mass. So which one do you want? Now with the term by itself, there's no way for you to flip this fraction-wise. Not, at least not in a way that would make sense. So if we start with the 100 grams, what we can do is we can put that on top of our T table and then allow our units to guide us. So from here, we want to be able to cancel grams. So which one of these terms would have grams on the bottom? And what you'll see really quickly is this guy down over here, right, has grams already on the bottom. So we're going to use that to cancel our units. So we'll put 0.001184 grams on bottom, 1 ml on top. That will get us to volume. Now, keep in mind, we have to get this to liters. So how could we do that? Well, using conversion sheets, you will see that 1,000 milliliters is 1 liter. And we can double check, did our units cancel? We'll see grams canceled grams, and then milliliters canceled milliliters, and we're in our final unit. So once we do that, what can we want to make sure that we put our value down here, which we will get 84.5 liters as our final answer. And we rounded to 3 sig figs because we had 100 grams. So this would be your final answer. So in this case, we use density as a conversion factor, whereas before we used it both as a formula and a conversion factor. This is the more common way, is that using as a conversion term. I hope this video helped. I know it was a little longer, but it's something that density is used so much in general chemistry and in first year chemistry. So I hope it helped, and I hope to see you all again in the future. And thank you all so much for listening. I hope you guys have a wonderful day. Bye now.